It is time for me to complete my report. Here's the assignment that I've been given. I've actually put it here at the top of my notebook, although I'll delete it before I am done with my report. The plain risk data come from a study published in the journal Risk Analysis in 2000. The researchers wanted to determine if perception of risk is related to worldview using Mary Douglas's grid group typology of worldview, analyze these data to determine the strength of evidence that perception of risk is related to worldview. As you know, if you've been watching this video series, we have been working throughout during the instruction about the topic, which is looking at a quantitative response variable, but categorical explanatory variables and modeling the response from that explanatory variable. We've been using this as an example throughout. So I have put up here into my R Studio another notebook that we built together in which we looked at the various aspects of this analysis. So I'm going to draw heavily on this notebook when I create this one. This was not done in report format, so really the big thing that's going on now is that we're going to have to convert what we did before into this report format that I'm going to use. So this was more of a pedagogical notebook, and I even mentioned along the way that I was doing some things that wouldn't necessarily be in a report. Here's an example right here where I created a dummy variables and showed you those. We're not going to be doing a lot of that in our report. So this will give you a chance to see exactly what pertains to a report and what was just me teaching and pedagogical in nature. So I've also written ahead of time some of the narrative that will go in here so that you don't have to sit around and watch me type. So I'll just be copying and pasting. I've already set up for reading in the data here, and I'm going to do that the very first thing to read the data into this plain risk object. And now I'm ready to go. So I'm assuming that you've watched all the videos so that you'll understand what we're talking about when we talk about the grid group typology and so forth, because we talked about that earlier. So let me go ahead and copy over what I have written. And I did not do this writing in an R notebook, so I'm going to have to change a little bit of the formatting. But otherwise, things should be in pretty good shape. Let's go ahead and look at this. Anthropologist Mary Douglas has theorized a two-dimensional social framework with the dimensions of grid and group. Grid refers to the degree to which individuals' choices are circumscribed by their position in society, and group refers to the degree of solidarity among members of the society. Using this framework, several worldviews can be expressed as placement in these two dimensions. Three of these worldviews are individualist, low on grid and group, egalitarian, low on grid and high on group, and hierarchist, high on both grid and group. And I actually think I misspelled. So let me go ahead and copy here. All right, so there's the hierarchicalist, high on both grid and group. This study will analyze individuals' perception of the risk of airplane travel to see if these three worldviews, that's the categorical variable, that's not three categorical variables, it's one categorical variable with three worldviews, are related to the perception of risk, and that's the quantitative variable. So I mentioned something about that quantitative variable now. Risk perception was on a 100-point scale, with 100 points indicating the highest perception of risk. Questions focused on the risk of traveling on an airplane every month. Here's the source of data, and I should italicize the name of the journal, so I will do that. And actually, I believe that APA style calls for the volume number to be italicized as well. Okay, so that's my description. Done with that. Now it's time for the analysis. So I'm going to start with a picture, as I always like to do. And I'm going to have that in figure 1. So I'm going to say the box plots in figure 1 illustrate perceived risk score statistics for the 3 worldviews. So let's go ahead and put in the box plot. So coming up here is where we created the box plot in this code chunk. So I'm just going to copy the entire code chunk over. And I'm going to make one little adjustment because I'm going to put in a figure caption here. So let me copy that. I'm going to put in a figure caption here. I'm going to do it in italics. And I'm going to leave some extra space between the narrative and the figure. And so what I'm going to do differently down here is take out that title because I've got a caption instead of a title. So let's go ahead and check that out. There we go. Now, those worldviews, we can do better than that. And why did it turn out that way? 1, 2, 3. Well, it turned out that way because when I read in the plain risk data, I did not create factors. So let's go ahead and go back here and copy over the commands that I use to create factors. There we go. So I'll go ahead and read this back in, run this again, and now we've got the nice titles to our 3 different worldviews. All right, everything there looks good so far. Let me go ahead and actually knit it and see how it's looking in a report format. Here it is. I'm not going to need this up here. In fact, I can go ahead and get rid of that right now. We know what the assignment is, so let me go ahead and get rid of that. Let me re-knit. Oh, I've got a code chunk showing, so let me take care of that. And I want the output to show, but not the code chunk. So one more time trying to knit. And now things are looking good. Okay, so I'm off to a good start here. Let me continue on. Now I'm going to say something about the plot and what I actually am noticing in the plot. So these plots suggest that individuals with individualist and, oh, I like that, individuals with individualist. These plots suggest that individuals with individualist and egalitarian perceive similar and higher risk than those with hierarchist. That's actually not correct. It's those with, let me make sure I coded everything correctly. Let's go back and look at the data coding for this. So it's 1 is individualist, 2 is hierarchicalist, and 3 is egalitarian. And when I look up here, 1 is individualist, 2 is hierarchicalist, 3 is egalitarian. So I just, when I wrote this narrative, it was done for some reason the other way around. So let's see. Those with individualist and hierarchicalist perceive similar and higher risk than those with egalitarian worldviews. The individualists are also more varied in their perceptions than those with the other 2 worldviews. Table 1 consists of 5-number summaries, means, and standard deviations for the 3 worldviews. I have to put that in, obviously. The wider interquartile, okay, let's go ahead. We're starting to talk about that table now, so let's go ahead and put it in, and then we'll come back here to this text. So this is going to be table 1, and it's going to be perceived risk, 5-number summaries, means, and standard deviations for worldviews. And let's come back here and see where we got that from. Here it is. So let's go ahead and copy actually the whole code chunk here. Okay, and I want to hide the chunk itself but show the output. So let's do that. Let's run this. And now let's see if the text matches. Table 1 consists of 5 number summaries, means, and standard deviations for the 3 worldviews. The wider interquartile range with higher scores above the median results in a slightly higher mean for the individualist. As you can see, a little bit higher mean than with the other two. The wider interquartile range, I already said that, then the egalitarian, though they have about the same median, and again, I'm consistently wrong. This is supposed to be hierarchicalist. I must have miscoded when I wrote the text the first time. And the mean difference of each of these worldviews with the egalitarian worldview is about 12 to 14 points on the perceived risk scale. Okay, so that matches now the text that I have here. And that's it for description. So really, this paragraph right here is the meat of the report. This is answering the question. And the question was about, do we see differences? And the answer is yes, we do, both in terms of variation, with the highest variation occurring with the individualist, and in terms of center, with the center of the individualist being the same as hierarchicalist if we look at medians, and a little bit higher if we look at means than hierarchicalist. So they're basically about the same, because remember that the median is actually not going to be disturbed by any skew. And so the fact that we have a little bit of slight skew here is resulting in a little bit difference in the means and the medians. But they're pretty close to the same, so it's not something terribly to worry about, but I also wouldn't make a big deal about any difference in individualist and hierarchicalist. But by contrast, there is quite a bit of difference here with the egalitarian. And I think I misspoke earlier saying the individualist had the highest range. Let's see. Well, it does. It's from 0 to 100. Egalitarian's almost the same, 1 to 100. Hierarchicalist is the same in terms of range. But the interquartile range, so let me look back at my text. Did I make a deal of that? The individualist more varied in perception. I think that's a correct statement. I talk about the individualist being more varied in the perception, and someone might say, but they have the same range. Look at that. They almost all have the same range. They do. But the variance in that interquartile range is quite a bit more, and that's also reflected here in that standard deviation. So it's about 5 points higher with the individualist than it is with hierarchicalist and the egalitarian. So I'm happy with this. And then the mean difference with the egalitarian is about 12 to 14 points from the other two. So again, like I said, this is the meat of what we're doing. Anything now we're going to do is going to be about can we make inferences outside this study? But in terms of what happens in the study, this is, I believe, the most important thing that we can say is what we have said, and the most important thing that we're going to say in this entire report, because inference is simply looking to see if, do we think the results are stable enough to take it outside of the report? And if the answer is no, then we need replication. But it will not negate what we found in this study for our particular participants. All right, so let me go on now to the inference part. First of all, I'm going to start by checking the conditions for valid inference. So let me go ahead and do that. I say the normal QQ plot of figure 2. suggests that there may be heavier tails in the residual distribution than we would expect in a normal distribution. So that's obviously comes from having looked at the QQ plot, so I need to do that. Let me go ahead and copy that part over here. Where did we have that? There it is. Okay. Now note, in order to do this, we're going to need a model. And so I need to go ahead and create that model. So where did I do that? Right here. There's the model. So let me go ahead and create the model, and then we'll get the normal QQ plot. Now notice down here I was doing a lot of teaching, and so I had all these plots that I'm not going to use in my report. So let me go ahead and create a code chunk. Let's put in the model. Then let's put in the QQ portion right here, which we now can do because we will have run the model. Okay. And we said that this was going to be figure 2. So let me go ahead and put in a figure 2. And I also remember from a past report that the QQ plot, let's go ahead and run it and show you what I mean, gives me that title that I want to get rid of. And I remember that we could get rid of that title, but I'm going to tell you I cannot remember how we got rid of it. So I'm going to go to help. I'm going to look under QQ norm, under help, and see, it's the main is what we need to change. So I need to put in main equals and put in a blank, and that should get rid of that title. There we go. Okay, and let me turn off this so we don't see the code chunk. Now, it says the normal QQ plot of figure 2 suggests there may be heavier tails in the residual distribution than we would expect in a normal distribution. See that? We have some over dispersion. Now, what is over dispersion going to do for us? What it's going to do with over dispersion is we're going to be actually looking at critical values that are not as far out as they should be. Therefore, our type 1 error rate's going to be inflated. However, notice what I say here. The fact that the sample size is 225 reduces this concerns because of the implications of the central limit theorem regarding the normal sampling distribution of means. So I'm really not as concerned about this over dispersion due to the central limit theorem. Okay, so let's see how it's looking so far. Let's go ahead and knit this and get an idea how we're doing. Figure 1, table 1, figure 2. I need some more space there with figure 2. Okay, try it again. Okay. Good. Looking good. I might actually even make a little more space between table 1 and my narrative there as well, to clean it up a bit. All right. Let's go on now to check the plot of residual versus fit. The plot of residual versus fit, figure 3. Well, I'm starting to talk about it, so let's look at it. And let's come back over here to where we created that. Actually, let me go ahead and copy in the whole code chunk here. Okay, and this is going to be figure 3. So I have some text that I created for that. Okay, I'm anticipating that I need a little more space above and below this narrative. And I don't need this main anymore for this plot because I'm going to have my caption instead of my title. And so what I say here is there's a slight positive skew in the hierarchist residual, but the variation within each group is consistent across groups. Let me actually, in order to be able to see this a little better, let me put in that, that 0 line. Let's see, I guess I didn't put it in this one, but I did up here, I believe, yes. So let's go ahead and copy this in. Okay, something's wrong here. Let's see. Looks like I'm supposed to be saying residuals instead of, no, because this is model residuals. So maybe that's what I should do. There we go. Okay, so there's our 0 line. And I believe, as I read this, that once again I've been consistent, and this is supposed to be the egalitarians residual. And the only reason I'm saying that there is a little bit of positive skew is because the cluster of points here and this being spread out, I can actually see that better up here, I believe. That, yeah. So notice that we have about an even lower quartile, upper quartile, but it's a lot condensed here down at the bottom, and then it's much more spread out at the top. A little bit of skew going on here as well for the hierarchicalist, a tiny bit for the individualist. So I'm going to rewrite this a little bit, suggest some slight positive skew among the residuals for the 3 conditions. But the variation within each group is consistent across group, and that's the main thing I'm looking at there. Do I have similar variances there? Now, also remember, I can come back up here and look at these standard deviations. So let me say something about that as well. And that was what, table 1? Table 1, yes. All right. So the bottom line is that I'm pretty good, well off. And if you're looking at this and saying, wait a minute, table 1, it was 5 more, it was the standard deviation here than down here. Remember, sampling variation, you expect to see differences, but these are not much different. I don't think I've talked about this in the previous videos for this series, but really unless you start to get more than twice as much standard deviation in one group than other groups, you're actually in pretty good shape, and it might very well just be sampling variability. And there's nothing anywhere near twice as much in one of these groups than the other groups. So I'm really in good shape in terms of both my homoscedasticity, and the pictures look very homoscedastic. And although I have overdispersion here, which would concern me, if I had 25 participants, that would be concerning, but I have 225 participants. So the central limit theorem probably puts me in pretty good stead. So now we actually have to do the inference, but I've run rather long in this video, so I think I'm going to go ahead and stop it here, and then we'll finish this report up in the next video.